Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece. And I'm going to read our information for the day. For math,
nice.
Yeah, thank you. For math homework help, please call in Bakersfield 636-4357. Everywhere else, you can reach us at 1-866-636-6284, or you can email dothemath@kern.org. We're online at dothemath.net and on social media, Facebook, Instagram, Twitter, and YouTube.
Nicely done, but not perfectly done. I think Mackenzie's giving you a little look because
we're online at dothemathonline.net.
Because Do the Math will bring you someplace else, so it's dothemathonline.net. There you go. See?
But you know, sometimes mistakes you learn. So
and our brain does grow when we make
there you
mistakes,
go,
and those
so
synapses fire off and things like that.
happens.
And brain growth today already.
There you go. All
See
right,
that?
I learned something new every
Not
day.
even a minute into the show. Hey, we do have phone tutors and tutors available on live programming for you Tuesdays and Wednesdays throughout most of the school year between 3:30 and 5:30. And we always have special guests in studio. We certainly do again today. We'll talk with some folks from Bakersfield College. So we'll check out those guys in a little bit.
Very good.
But first of all, we have our social media problem of the day to deal
ready.
with. All right, so you ready?
Yep.
Let's take a look at it. 3/4 divided by 1/3. So let's think about what students are going to see this for the first time. Probably in about 5th grade, they'll see this for the first time.
Okay.
And a lot of students are cool with adding and subtracting fractions.
True.
And with unlike denominators, they figure I got to get a common
Common denominator.
But with multiplication and division, it's a little different.
Right.
And they do multiplication first because they can just multiply straight across and then simplify. But when it comes to division, it throws a lot of kids off. So what is the first thing you'd like to do, or what's the first thing you think a 5th grader might want to
Well,
do with
I
this
guess there's a
problem?
few ways I might think of it. If I was going to visualize it, I would probably go ahead and, make either a square or something like that, and then break it into my 3/4,
Okay.
and then go ahead and say, okay, I need one. I'm dividing it into thirds, right? I could do that. Likewise, we learned then that what we're doing when we divide like that is we're actually multiplying by the reciprocal because we're
Right.
breaking it
And
into 3 pieces.
That's the key right there, I think, is using the word reciprocal.
Right.
Because they'll know that 3/4 divided by 1/3 is the same thing as multiplying it by
the
3.
reciprocal, right? Yeah, right.
So if we do that, if we have 3/4 and we multiply it by the reciprocal of 1/3, which is 3/1, which is simply 3,
Yep,
we end up with 9/4.
correct.
And I don't see 9/4 anywhere on there.
I don't either.
Is there anything that would be the same as 9/4?
Yeah, for sure. So 4, we're doing 9/4, meaning that we have, 4, or we have 2 sets of 4 that we could go into 9, and then I would have my 1 left over, so it would be 2 1/4. So I'm looking at C.
You're feeling good about C?
I'm feeling really good about C.
Because B has a 9.
That's nice.
All right. I'm just making sure.
I just, that's good. I appreciate that.
And D has a 4th on the bottom also.
Yep. But it was 9/4.
All right, so you're going to go with C.
I'm going to go with C.
All right, let's take a look and see if
Okay.
C is correct. C is indeed correct. You are well on your way
We're
today.
learning, and I've done well on fractions. This is my day.
This is a big day.
Awesome.
You know what? We still have about 55 minutes to go, though, so we'll
we'll
make
do our
sure the
best.
day keeps on going
I
successfully
am
right now.
5/60ths of the way through. Wait.
All right, time now for today's Math in the News. All right, today's Math in the News. As promised, we have special guests in studio from Bakersfield College Industrial Automation. We have Carlos. How are you today?
I'm doing well. How about you?
I'm excellent. So what is your role with the college and this program?
So I am the program manager for the Industrial Automation Bachelor of Science degree.
how long has this been at Bakersfield College? Because it hasn't been there forever.
Well, this program has started back in 2016. And so now we're we're a permanent program. We're here to stay now. So it was a piloting program at the beginning, but there was legislation signed a couple years ago from the governor to make our bachelor's degree program permanent.
Because I know BC's a community college.
Correct.
But they've got it where now you can go to BC for 4 years to get the full degree.
Yes, so industrial automation was our first bachelor's degree program, and now we have a second bachelor's degree program in research technology.
Okay, this is pretty cool that you've got going on with this robotic arm right here, and you've got Colby, one of the students in the program. So Colby, how long have you been in this program?
So I am a senior, so I've been here for 4 years.
Okay.
But I actually started in this track through a thing with our high schools.
Oh, so what was it that you found in the high schools that led you to this? Was it through CTEC, one of those programs?
Yes, it was through CTEC. Well, back then it was still just ROC.
Okay. And I think last time, because we see each other quite a bit at these symposiums and things like that,
Yes.
and you've always got some interesting things, and a lot of kids are always attracted to robots and what you guys are doing at Bakersfield College. So Colby, can you explain a little bit about what you've got set up here and what the robotic arm is doing right now?
Okay, so our robotic arm here is doing what we have as a palletizing program. So the industrial application of this would be we'd have like a giant conveyor belt, say it has a bunch of packages from like, say Costco, like bulk packages of food. Bigger conveyor, bigger arm, and that'd be going to like a pallet to go onto like a shipment truck.
Okay.
So we don't have to have workers hauling boxes back and forth. We can have a robot that can put them on our pallet.
Especially if you've got things that are considerable weight.
Yes.
Because obviously you wouldn't have people physically just picking up the boxes. They would have pallet jacks and things like that probably.
Yes.
But this can take care of everything and a little more efficiently as well. Because I can
Yes.
see that you've got them going exactly where you want them. They're lining up. It's not just a mess that they're just dropping
Yes.
it on, something like that. And this is all you programming the arm
Yes.
to do exactly this.
Exactly this. So I gave it the point at which it picks up, and then 2 points or 4 points around the sides of this pallet, being these 4 here. And then it did the math and calculations to do the rest of that.
So, but you need to know what's in that program in order to program it correctly to do this though, right?
Yes.
It's not like a kid just goes, all right, well, I'm just going to hit a couple of buttons and I know what I'm doing and I can program
Yes.
this arm to go
There,
and do whatever
this
I
is
want.
a few, I would say years, because it's been years since I started working with this robot. But it has been quite a long time that it's taken me to actually get it to run this properly. As you can see, still not perfect.
But Colby did really well because you can see he started doing the programming in about 20 minutes ago, and he got it down this well. So
what else can the arm do? Are there other applications that you can do other than moving boxes, like in
Yes.
real life applications?
So this is obviously a super easy application I was able to make to show off. But these arms are super versatile. We have several different types of grippers you can put on the end of here.
Okay.
Ranging from a gripper like this one where it's just pinching to ones that have vacuums, so it can pick up without actually physically
Holding
forcing.
onto it like
Yeah.
that. Okay.
So you can pick up from much different angles. Depending on the size of the robot, it can move different objects.
And I would
And-
imagine the sensitivity on whatever is at the end, because you don't want this
Yes.
thing crushing
Yes.
things.
One interesting thing about this robot that I can kind of show off as it's coming around here is if someone gets in the way, it stops immediately.
Okay.
I barely felt anything. And then all I need to do is hit a few buttons and resume. And it goes right back to where it was.
Because accidents will happen.
Yes.
and that's the difference between a Cobalt. So this is a Cobalt.
Cobot.
Cobot. And then the other ones, we have industrial robots that are a lot bigger, that are at bigger manufacturing plants. So industrial robots would not, they have cages around them
Okay.
for safety
So nobody can
purposes.
get near them.
Nobody can get near it. Because once you program that robot, it's running whatever course it's running. Now, a Cobalt, it's a lot different because it has safety sensors all around and can work along with the person.
Now, what about repairs and things like that? So there are obviously people that are going to need to program these robots, but then is it something totally different, or would these people be able to repair it also?
So that's the great question, because our program teaches our students and trains them to not only program, but also maintain and troubleshoot these robots. So whenever they're not working like they're supposed to, then they have to go in there and try to troubleshoot and figure out what the issue is. If it's something that's way over their head, then we would have to call in technicians from the robot to come in and fix
Okay,
it.
so problem solving is a big thing that students need to be able to do as well.
Yes, exactly.
So is this something that you do on your own, you kind of are doing this, or is it a team of students that are working together?
So I learned this in 2 different situations, being at ROC/CTech and here. And it's been an interesting combination, because at CTech, we had 1 robot for the whole class, so it was a big group thing, so you had to work with everybody.
Okay.
Where here at the BC, we have, 5 robots? Is that right? 5 robots?
Yes.
Yeah, we have 5 robots for a smaller class. So it's a lot more individual stuff. So I've learned more stuff while at BC, but I feel like I had more meaningful and quicker learning when I was with a group of people, because it was not just my thoughts. It was everybody kind of working together.
Input. A lot of students in, I know, elementary school are learning how to code. So those skills will probably help them if they're looking into something like this later in their education.
Yeah, definitely. And that is the reason why we started our early college pathway. So now high school students can start taking our classes just like Colby did through ROC, CTech. We have other couple high school partners that we have the program in. So students get a head start into our bachelor's degree. They get college credit in high school.
Okay. Nothing wrong with that.
Nothing wrong with that.
Don't even have to pay for it. Then, right?
Exactly. It's free for them, and it's at their high school. They don't have to worry about transportation, materials, books, or anything.
And even when they do go to Bakersfield College, it is a lot more cost effective than going to other major universities where you have this right here in the backyard.
Yes, correct. That's a big sell for our program. So our bachelor's degree program, the average cost is about $11,000 for all 4 years.
Okay. That's amazing.
It is.
It's $11,000, seems like per semester, at the very least for some other schools. I know that you guys have an event coming up, and when is this event and what is it for?
Yeah, so we have our annual event coming up next Friday, October 20th, which is Manufacturing Day.
Okay.
Which is a day to bring awareness to manufacturing. And so we have a lot of industry employers that are going to be showcasing what modern manufacturing looks like. So like Colby mentioned before, you would have somebody picking up boxes and putting it on a pallet. Well, that's not the case no more. Now you have a robot program to pick up packages, whatever the product is, and put it in a box that then puts it on a pallet that loads it up onto a truck that takes it to your nearest store.
Okay, we can see some footage here of one of the symposiums, and that's one over at CTech. And I remember, because you've come in before with Spot, is that correct?
Yes.
The other robot, like the dog?
Yes, a robotic dog Spot from Boston
Spot.
Dynamics. Yes.
Yeah, so that was fun. That was one of the first times I think you guys were able to
Correct.
come in with one of those. So that's coming up on the 20th.
The 20th, yes.
And it's at Bakersfield College.
At Bakersfield College. And so last year we had over 1,800 students show up for this event. It's strongly supported by our industry partners because they need people in the workforce.
Right, and they'd like to have them right here.
Exactly.
All right. So this is certainly amazing. I mean, I'm sure you're digging this whole program, right?
Yes, it's
So
a lot of fun.
you're a senior now, so do you have plans on your next steps, or you're just kind of getting through this year?
I'm kind of just personally getting through this year. A lot of people I know from some of my peers in class do have ideas for the next step. I'm a little bit more chaotic in my scheduling because I would like to stay in the Valley, which is one of the reasons I liked the fact that this program existed.
Okay.
Because I'm not all that, I guess, enthused to get out of Valley. I like being here in the Kern
There's
River.
nothing wrong. I mean, you like
Yeah.
it here, this is where you're from, you want to do stuff here, so totally understandable.
No place like home.
Yeah, no kidding.
Click your heels and there you go, huh?
Exactly.
All
But
right.
what's great is our program gets our students careers on the top 5 industries in Kern County. So they can go into oil and energy, they can go into agriculture, they can go into distribution, manufacturing.
Right, and we were speaking with someone yesterday, and this is in the top 4
Right,
in the country
right.
of places to find work like that. So kids don't need to go someplace else. It's right number 4 in the country, not number 4 in the Western United States or Kern County. It's number 4 in the country. So excellent. I'm certainly glad you guys had an opportunity to come in and share this with us. And I know a lot of students are probably digging on this right now going, hey, you guys got this stuff at Bakersfield College and I want to get into something like this. But that is today's Math in the News. Going from blocks to base 10 blocks right now with Mickey, and let's talk math.
Hi, I'm Mickey. Today we're going to explore base 10 blocks and how they can help us add, subtract, and even do some higher math with decimals. To get started, let's look at a subtraction problem. We have 42 minus 23. So I notice over here on the board, a lot of students recognize this problem and right away go, hey, wait. I start in the ones place, just like I was taught, my smallest place value. But I have 2 in the ones and I want to take 3 away. Well, that's a problem for us. Let's explore why. Over here I have base 10 blocks. Base 10 blocks help me visualize values in mathematics where a 10 rod is worth 10 or in the tens place, and these 1 units represent 1 in the ones place. Other options that we have are also a whole unit that also represents 100 in this case, but we're not using it on this problem, so we'll put it away for now. But we are using a subtraction problem, so I have 42 and I want to take away 23. I'm going to bring these over to the side to remind me that's my goal. So my goal was to take away 3 ones. Unfortunately, I only have 2 ones and that's a problem for us. As we go back over here to the board, a lot of students would look at this problem and say, hey, I know what to do. I need to borrow. But borrowing is not a real thing. In math, we don't borrow things and give them back. Once we use them, they're gone. So really what we're doing is called regrouping. Regrouping looks like this. I regroup the 4 in the tens place and it becomes a 3. A lot of students say, well, I just borrow because my teacher told me to. Here's the actual reasoning why. And they say, put a 1 on the 2 to make it 12. And they say, well, that works, but if I ask a student to explain it, they're not quite sure why math works that way. Let's explore it with the base 10 blocks. I had the 2 and the 1s like we had, but unfortunately, I need to take 3 away and I don't quite have enough. The nice thing is, this 10 rod can actually be split into 10 ones. If you can see those individual pieces, it shows that it represents 10 ones actually put together. So what I do is I regroup. I take this 10 rod, I move it away, and in I get 10 units. 1, 2, 3, 4, 5, 6, 7. Let me grab 3 more. 8, 9, 10. So now, if I count these up, 2, 4, 6, 8, 10, 12. Now I have 12, just like my problem on the board over there. I saw 12. Now I have enough to take away 3. I take the 3 away that I wanted. Boom. But I have to remember, I did regroup, so I don't have 4 in the tens anymore. And that's why when we write our problem down, we cross it out and put a 3. Now I have 3 tens left, which stands for 30. 31, 2, 3, 4, 5, 6, 7, 8, 9, 39. Let's head back over to the board, check out our math, make sure it works. Oh, but wait, we're not done yet. We almost forgot. Take away those 2 tens. Take away my 2 tens. Now, I'm left with 19. Always double check. Make sure you've done all your math before you check your work. So on the board, I have 12 minus 3 leaves me with 9. And I had 4 tens originally. Remember, we had to regroup one of them to turn this 2 into 12 to allow me to subtract in the ones. I'm left with 3 tens. I took 2 away. 1 left over. Hey, our answer matches 19. So now you see visually what regrouping means. So again, it's a way that we can visualize subtraction when sometimes my teacher told me to, or borrow because you have to, doesn't necessarily help a student understand why subtraction works the way that it does.
All right, thanks to Mickey for that, and always fun using manipulatives in the math classroom, a ton of them to work with. Do remember we have phone tutors available most Tuesdays and Wednesdays throughout the regular school year, phone numbers, emails, and all sorts of good things at the bottom of your screen throughout the program. All right now we are fortunate enough to have a Skype call with a couple of folks from NASA. We've got Cryss and James with us. Good afternoon to you.
Hello.
Hello.
Nice to have you guys with us. I know you guys are always busy and we are fortunate to be able to speak with you guys. And as far as what you do, you are testing things before they go on any aircraft as far as NASA goes. So Cryss, you're in charge of the shake that happens with everything, correct?
Yes.
So before a piece, it doesn't matter what the piece is, if it's going on any type of aircraft, it has to go through this test of shake. So explain to the students a little bit about what exactly that means instead of you just taking it and going like that. It's a little more complicated than that.
Just a little bit. So we have vibe tables that everything goes on behind me. So what happens is we put it on there and it goes, there's going to be a video.
All right.
So everything, if you see the movie Top Gun and they talk about G-forces when they're flying their airplane, everything on the airplane has to be able to withstand the G-force of whatever that airplane is gonna be able to fly through. And so what we're seeing right now on the screen, that's a G, or several G's in this case. And so those components have to be able to maintain structural integrity when it's on the airplane and back down at land to function.
Okay, so once you test this component, do you retest it again to make sure, or was it the one time that you've done it and it's good to go?
So we actually test it the whole entire time it's on the vibe table, and then we test it afterwards. We test it in the cold chamber, which is James is going to talk to you about that in just a minute.
And how far in advance do you need these components, and how long do you have them?
Each test is different. So sometimes we test these for 30 minutes. Sometimes we test them for 3 minutes. So our test plans are various in length. And so sometimes we have 2 weeks to prepare. We have to build fixtures for them. It just depends on.
So Cryss, are there many times when you get a component, you go, all right, we need to test this for 30 minutes, and it's going along smoothly, and after 29 and a half minutes, it just collapses and it stops. Something happens where you're like, we just almost had that thing for 30 minutes. How long again is it before they modify it? I mean, what's that process like?
So we stop it immediately during the test once it fails, and we will open up the component, see what has failed, and then the engineers take over, and if they can fix it right then it gets fixed. Sometimes we can fix it immediately. Other times they have to send it back to the manufacturer, and they fix the problem and bring it back to us, and it could be a month, 3 months. It just depends.
Okay. So how did you get interested in this type of work and start working with NASA?
So I've been in testing for about 10 years, and I just got lucky. NASA gave me a call, and I said, I'm on my way.
Easy as that, huh?
Yes.
All right. Hey, James, so you work also with testing, but instead of moving things around, you're heating them up. So tell us a little bit about that and some of the temperatures that you get these to.
Yes, sir. So not only do we heat them, we also get them pretty cold. We send them down to sub freezing temperatures. So this chamber here behind me, this is our large, we call it the large BIM coat. So it's a 6 foot by 6 foot by 6 foot chamber, so you can walk into it. It can go up to 100,000 feet simulated altitude, and it can go up to 500 degrees Fahrenheit and as low as negative 100 degrees Fahrenheit. And that is also to simulate temperatures.
So the 500 degrees Fahrenheit is the hottest anything would ever encounter as far as one of the parts on any aircraft?
Yeah, it's a bit exaggerated, but yes, they get up to some pretty high temperatures, depending on the geographical location that the aircraft would be flying, the altitude, the time of year, of course, seasons. They all take account into the temperatures in which the components on the aircraft will can or should be able to withstand.
Okay, so if you're testing a component and you can get it up as high as you want and as low as you want, do you do that with all of the components where you get them as high and as low as you can, or are there times when it only needs to make sure that it only gets as high and you don't need to worry about the lowest temperature?
There are times that we've only tested one temperature or the other. And there are times that we tested temperatures without actually simulating altitude or height for the aircraft. So yeah, we'll go up to about maybe 140 degrees Fahrenheit, maybe somewhere up in there, or sometimes a little bit higher without actually dropping down. But normally we try to test out both low and high ranges.
Okay, and once you get it to the high range, whatever it is that they want it to be tested at, let's say it's 140, once it hits 140, is there a certain minimum amount of time that it has to stay with that amount of heat on it?
Yes, sir. Once again, all of our tests depend on the actual component under test. So sometimes, I mean, we spend 5 minutes, 30 minutes at a certain temperature. There's been times where we've actually had to run 24-hour tests and keep a temperature at keep a device at a certain temperature for multiple hours, or sometimes even 24 hours.
All right, so James, is there anything that you've put in one of these and you were like, all right, it just all of a sudden just melts immediately, something happens, and you're like, whoa, there was no way this thing was ever going to pass that test? Does that happen often, or has it ever?
Me personally, no. I've never put anything in there that messed up, or not messed up, but that melted or anything like that. Most of usually our devices that we test they have the materials they're built out of the materials to withstand those type of temperatures. So things melting, other than sometimes, I guess one time somebody left a marker by accident, and it kind of exploded, but that wasn't even due to temperature. That was because of the altitude.
Okay, yeah, the pressure on it. All right,
Yeah.
So James, did you get lucky like Cryss falling into NASA, or how did you end up there?
Yeah, I mean, it's luck. I mean, I'm happy to be here. I was actually working in Afghanistan, and I was ready to come home and be with my family. So my wife at the time, she found the job position, and I applied, and the rest is history.
All right, so if somebody is watching right now, either Cryss or James can answer this. If a student is looking at this and going, hey, it seems kind of interesting, I'd like to go do something like this, are there classes that they would need to focus on in order to attain employment like that?
Yeah, I guess, yeah. So what was that, Cryss?
Any STEM classes, I would say any science.
So just keep going
Yeah,
with science and math and you're going to be fine.
Yes.
Yeah, pretty
Yeah,
much. One class that we kind of take as a on-the-job training that our employer pays for is a vibrational fixture design built for a class or a course that kind of helps us along the way with the test equipment that Cryss is showing everyone. That's a good class to take. So if you can do anything with vibration or learning altitude or just learning aerospace in general, could help out a lot.
All right, well, I know there's a lot of young students always fascinated with everything that goes on at NASA and space and flight and things like that. So the extra push for the math and science classes, we always appreciate from you guys. So thanks for taking out some time with us today.
No problem.
Yes, sir.
Thank you. All right, 636-4357 is the phone number. We have Colby, who we met earlier from the Bakersfield College Industrial Automation Program, has been kind enough to stick around with us this afternoon. Yeah. And one of the problems that you and Cece are going to be working on is a problem that some students are working on, and it's an art problem where they have a grid, and it's a 10 by 10 grid, and they can color in the rectangles and squares however they like. But then based on the colors they choose, which would be red, yellow, blue, or remain white, they have to figure out the percent of each color and then represent it as a percent, a fraction, and a decimal. So I'll let you guys take it away.
Okay, so you said blue, red,
and yellow,
and then
and you can
white.
leave some white if you like. Now you don't have to use all the colors. You
Okay.
can go, we're just going to go blue and white, or whatever you want to do.
Okay, all right. So if you want to grab that one, and then let's see, if you will tap, oh no, I guess you already are red. Okay, so I think we're just going to go ahead and color you can pick some that you want to be red, and I'll pick some that I'm going to make blue, and maybe we'll do a few yellows and see what we do. So I'll make this one blue. That looks good. I'll go blue over here, and then maybe blue up here. All right, so go ahead with some reds.
It's been so long since I've used a smartboard.
They're fun.
They are so much fun. We'll go with this one.
Okay, nice. All right, and then we'll throw some yellow in there. Let's see, and we'll go yellow, yellow, and yellow. Okay, so with that done, we're going to go ahead and figure out the percent of each color based on, of course, the total area, which is 100, because we had a 10 by 10 square. So you've got red, so if you want to talk us through maybe the percent of that area for red, and we can go from there.
So, I mean, for the way I'd be doing it myself is going each section.
Yeah, absolutely. I think that's great.
So I'll just use black for this.
Okay.
So we got 5 and 2, so that gives us 10. So
Lovely.
there's 10% in there. This one is 2 and
Yeah, we got the 3 over here.
it's 3. Okay, yeah, 2 and 3, which is 6.
Okay.
6 there, and then 3 and 2, so that's another 6 here. Then you add those together, so you've got 12. That comes up to like, what, 32?
So 12
Wait.
and then 10 more.
Wait, no, I did that wrong. That's 20.
There you go.
It's
There you
22.
go. Okay.
And then I guess the next one.
So yeah, so actually, if you'll just go ahead and throw that up there, just we'll do
Oh.
22% is red. And,
terrible.
oh, you're fine. You can erase. It's just like a pencil. There you go. Okay, so 22%, and then yeah, cool.
Red.
All right, awesome. I've got the yellow going on, so I'll go ahead and say, all right, this one I'm going to give it a 25 here, and then this one is a 4 by 4, so there's 16, and I always get too close and I erase things. 2 by 2, because I've got the 1 and the 1, so 2 by 2, that gives me 4, so 16 is 20, so that's going to be 45%. And now, how did we know that it was? How did we know it was 45% and 22%? We kind of glossed over.
We did
that
kind
a
of
little
gloss
bit.
over
Yeah.
that part.
What is percent? Percent means out of.
Out of 100.
Right. Okay. Good. So let's go ahead and I'm going to back up just a little bit. And I'm going to take my 45. I'm going to say 45 out of 100 is the same thing as 45%. And we're going to turn that into a decimal too. But if you want to fix that one, and we'll say.
That's fine.
Yeah, it'll work.
100.
Okay. Now, the question, though, of course, with my fraction and with your fraction, can we simplify them?
Definitely.
Okay, so go ahead and simplify yours. Tell us what you're simplifying, what strategy you're using to simplify.
It's been a while since I've done simplification.
Ah, that's good. Then I'll do mine first. Okay,
Yeah.
we've got 45 over 100. I know that I can go, I'm going to rewrite it, 45 over 100. I am going to divide by 5 over 5 because I know that 5 over 5 is simply 1, and dividing anything by 1, of course, is the same thing as itself, or it's equivalent to. So 45 divided by, we're dividing, well, I guess I'm not actually dividing by, well, since we did our earlier problem where that would be multiplying by the reciprocal, I probably don't want to say that. I want to say that we can divide both by 5. I guess is probably a better way of doing that. So that's going to give me 9 over 20. And I can't simplify any further than that. So 9/20ths is my final for yellow. All right, and then go ahead with your red.
Even with that, I'm still.
That's okay. So we're saying what can we divide into both the 22 and the 100? Both of them are even numbers, so we know that we can do
2.
Right, absolutely. Okay, so then that's it. So 22 divided by 2 is?
Is 11.
There you go. And
then that would be 50.
And since 11's prime, we're done, and that's it. Okay, so then we've got blue, and then, blue, and then I'll let you do the other parts that are left.
Okay. So 3 and 3, which is 9.
Okay.
which is the same as the
There.
palettes I was using earlier.
That's right. 9.
That could be done better.
That's all right. Well, we got it. We got it.
Yeah. And then this one over here is 2 and 2, which is 4. And then this is 4 and 1, which is also 4. So that is 8. That is 17? Yeah, 17.
And then can we simplify that?
I don't think so.
Because 17 is
Yeah.
prime, so we're stuck there. Okay, I'm going to go ahead and do this one. 3 times the length of 4, that's 12. I've got 2 times 2, which is 4, so 12 and 4, that gives me 16 out of 100, which I can go ahead and I can simplify that by 4s. So that's going to, oh, well, can I go further than that? Nope, that's as far as I can go. Divide by 4, that gives me 4. Divide by 4, that gives me 25. So I've got 4 25ths. Which was also, like we said before, 16%. But how do I know? Oh, well, I guess we talked about that this is out of 100. But how do I know? Where else am I going? Oh, decimals. We forgot to talk about how to do this as a decimal.
So you're fine. Right now, you've got them all in percents.
Yes.
So what I would do is maybe just write 45%, 16%, 22%, 17%.
Yep.
And then turn those into decimals.
Right. So,
22, 45
yep.
of 17 and 16.
16.
And then
Okay,
those are all
so
in our percents.
So what did you want us to do, Mike? Well, you just
So
wanted us to change
you have
these to
them as
decimals.
percents, so now
Right.
write them as decimals.
Okay, so we're just going to write them as decimals.
Right.
So we know that in order to this, if I was going to divide this, we would get some sort of decimal answer. And we can do that. We can do some long division. We can get there. But here, because again, we're saying it's out of 100, I'll use, I guess I'll leave it with black. All right, so 16%. I know all I'm doing is I'm saying 16%. I am moving my decimal 2 places because it was over 100. So I know this is the same thing as right there.
There you go.
Again, I'm here. I can look at this and I can go, wow, I could definitely divide that, but you know what? That's going to get ugly real fast. I don't feel like doing some long division. I'm going to go back here and say 45%. Move my decimal. I know that it's 0.45, and those are the same thing.
The best part about percents and decimals.
There you go. All right, so what have you got over there for your red and blue?
So again, same thing. It's out of 100. So you've got your 22% from over here. Move it over twice, and you've got 0.22.
Okay.
Down here, same thing with 17, because percents are that easy to convert to decimals. You got 17%. Move it over to 0.17.
Nice.
So that's it. So you took that 10 by 10, you broke it up into different colors that you wanted to do as far as squares and rectangles. The whole thing adds up to 100%, which is exactly what it should be. So you guys did nice work on that. Colby, for some great work so far this afternoon. You've got yourself a meal courtesy of our friends at Grill & Burger. So congratulations on that. There's a new little graph. Get the dancing burger right there. It danced its way right into my mouth. We'll be back with more right after this.
We are SDSU, a campus without borders, a university driven by purpose and heart, and a community that dares us to learn more, do more, be more. This is a place that inspires us to break down barriers, where the classroom extends from San Diego to cities, towns, and villages around the globe. At SDSU, we have an admirable tenacity to make change happen for our students and for the communities we serve.
For myself as a young freshman coming on campus, I felt like this was such a place that symbolizes independence and growth and opportunity. The passion in the community that, students want to grow other students, and then you also have professors, faculties that are willing to step out of what they're doing to help other students be the best that they can be. So I think it's the synergy and the energy that people is all infectious of wanting to help and wanting to see community and wanting to see the best students come out of SDSU.
We have outstanding faculty, staff, and students who see themselves as part of a broader community and who are willing to collaborate and support one another for the common good. And the common good is really to allow for greater equity and social justice. Our students really have an opportunity to explore current issues that impact not only our community, but the world beyond.
SDSU is living on the edge and the forefront with a trans-border, research-intensive university that uniquely positions us for both regional and global impact. We are known for our fierce commitment to excellence, our passion for service, our creative work, and our growing research. This focus is woven into our academic curriculum with expansive study abroad options and international opportunities at our university in Tbilisi, Georgia, and our new site in Oaxaca, Mexico. Shaping the community is in our DNA. We are an economic engine for the US-Mexico border region and a propelling force for society, creating thousands of new jobs and educating the city's future leaders. Research is flourishing at every corner of the campus and extends from Mexico to the mountaintops. We are creating technology for artificial intelligence and for space missions, discovering the habits of savage geckos, and creating social justice through comics.
We started the lab with a table that we got from the surplus. We are sitting now in a facility that's about $3 million, furnished with the state-of-the-art equipment. We also have amazing students that allow us to undertake these very challenging problems and work on them. So it's a combination of the facilities that we have built here at State and the capabilities and the aptitude of our students to undertake these big challenges.
At SDSU Imperial Valley, the virtues of a small research university are combined with CSU access and affordability. There, we are building a new STEM site that will drive new educational and economic opportunities for the Valley.
Impacting the community is part of our DNA, and when our students come to SDSU, we engage them at every level of research and teaching so they can be part of the broader conversation. So our students in the Imperial Valley campus have the wonderful opportunity to be in a research institution that provides experiences in a liberal arts setting.
In San Diego, SDSU Mission Valley will unlock education and economic development for the region, including the opening of Snapdragon Stadium. The Mission Valley site will offer space for innovators to dream big, outdoor enthusiasts to explore, and education for a new generation of students, with plans to increase enrollment by up to 15,000 students.
The active role in social justice and equality, and just seeing how happy the students truly were just walking around campus and being proud to be an Aztec, that's something that I really wanted to be a part of.
There's just such a unique blend of diverse people from all different backgrounds at San Diego State University.
San Diego State students are passionate and incredibly driven.
We are a determined group, a group that has passion, that wants to dive into leadership, and that wants to see the best out of their community.
I feel like I'm constantly inspired and wanting to do more.
This is where we feel at home and where our story is built. This is where access and excellence converge to create a more equitable, compassionate, and prosperous world. This is SDSU.
We do have Colby, a student at Bakersfield College in the Industrial Automation program, and you're a senior this year.
Yes.
So you've been with it
Finally.
for a long time. Pretty impressive with that arm over there before.
Yeah, it's a fun thing to program for sure.
So one thing you had to do is, as you were growing up, going through elementary school, junior high, and high school, you had a lot of math classes. You have taken math every year of your life so far while you've been in school, correct?
Besides like 1 year because of some COVID stuff, but.
Okay. So basically you've been taking math all the time, as many kids are going to have to do.
Yes.
So tell us some of your memories from some of your earlier schooling. What do you kind of remember about math, things that may have been really easy for you, or they gave you a bit of a problem, you had to kind of work through them a little bit?
Luckily for me at least, both my parents were originally teachers as well, so they were able to help me outside the classroom, as well as my dad having a degree, I can't remember what degree, but a degree in math.
Okay.
So math usually came pretty easily to me. It was weird because I'm right in that one generation of like students that every year something new was getting involved. So like we're starting to be able to use calculators in the classroom, then I was one of the first people to start having like the Chromebooks and all that stuff, all the technology.
Well, think about this. I know you're a little younger than I am, Cece, but I remember the good old days when they go, hey, guess what? You guys are going to learn the metric system now. It was an experiment back in the 70s. I think it was actually 70 or whatever. Yeah. But that was a lot of fun to have to go through. And then they were like, all right, well, we're not going to even bother with that anymore. Yeah. So were there any things that you did, maybe courses possibly in high school, that you took that were a bit more challenging for you?
Geometry was, it was a little bit harder for me because I was just more based on the numbers and stuff, and then it was like trying to figure out shapes was a jump for me,
okay.
I'm going to say.
But you got through it all.
Yes.
That's the key right there, right? Perseverance and struggle, and that's the key, is when you struggle with it, you'll learn it a little bit more also, right? Because if everything was easy, you'd never learn anything.
And I think some students do have that difference between some of them really like algebra and some of them really like geometry, just whether or not they
you find your niche.
visual. Yeah.
You know what I mean? Some
am I
kids
good
are
at
able to
visualizing, or am I better at kind of the abstract?
Right. And if you can kind of be open to all of them, even better. But that's why you get expertise in one area or another. All right, you guys have a problem that you're going to work on, so I've got it right here. I'll read it. And so given that 75% of a certain number is 88, what is 3/8 of the number? So 75% of some number is 88. We want to know 3/8 of the number.
Okay. So when you look at this, is there anything that jumps out at you that you think of?
I mean, one easy one is the fact that 75% itself is 1/4.
Okay.
Not 1/4, 3/4.
Right, okay.
So it's able to be written is not 1. I'm
That's
always
okay. We
bad
got you.
at writing.
And we know that because 75 over 100, we can go ahead and simplify that down to 3/4. Okay, good.
And then, since we have 3/4 of the number, we know that 3/8 is half of 3/4. So, divide that. Is that right?
So we're actually going to end up, well, I mean, I guess it depends on how you're wanting to write your equation, but
yeah.
You're good.
That's one thing I struggled with.
You're
was
fine,
writing
you're fine.
it.
So we know. So if we know that 3/8 is half of, because if we're multiplying it by a half, so if we just said, okay, times a half, so it's a half of, and then we multiply straight across. So the 3 times the 1 gives us the 3, and the 4 times the 2 gives us the 8. So we know that that's half. So if 3/8 is half of 3/4, then 3/8 is, of this number is?
That would be half of 88.
Okay, which is?
Which is 44.
Okay, so we're saying it's 44. Okay, so you said it's 44. Okay, I'm going to do it just a little bit different. Bear with me, okay? So 75%, like you said, it's 3/4. So I'm going to break this picture into fourths. So 3 of them is 88. So that means that each one of these boxes is 1/3 of 88, so that when I add them together, I get 88. So for me, if I'm looking at it visually, I might do this, where I know, again, like I said, 3 of these 4 boxes have to add up to 88, so I've got this. Now, I'm going to say, all right, I'm looking for 3/8 of this. Well, I had fourths, right? So if I have fourths, if I cut each box in half, now I have 8s. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I'm saying, okay, I need 3/8. So I want like this box and this box. I'm circling 3s, but that's not really what I want. I just want one portion of those boxes. So I say, all right, I need half of, because I broke it into a half. So I'm saying, what is this a half of? Well, 88/3, if I take a half of that, is 44/3. This one's going to be 44/3, and this one's going to be 44/3. And if I add that together, I'm going to end up with 44. So, or I could multiply 44 over 3. I've got that 3 times. So when I multiply that, I'm going to end up with 44. So we can do it either way. We can visualize it, or we can do that, and we're good to go.
There you go, nicely done. So both of those ways solve it, and there are probably 18 other ways to do that as well.
For
and
sure.
that's the beauty of mathematics. The more ways you can solve it, the better it is. All right, you guys ready for one more?
Okay, you ready? We'll
All right.
yep, there you go.
So there's, oh, you know what? News came out today about the red dye being eliminated in California in a couple of years, as far as
Okay.
M&Ms and
Yeah.
Skittles and things like that.
Yep.
So we're going to do a candy problem right now.
Fabulous.
All right. So jelly beans.
Okay.
Okay. We have red, yellow, and orange.
Okay, hold on. Red, yellow, orange. Got it?
5 are red,
Mm-hmm.
7 are orange.
7 are orange.
2/3 are yellow.
2/3 are yellow. Okay.
How many are there altogether?
Okay.
There you go.
That's not 70. Orange. Okay, we got it. All right, your thoughts. Go for it.
Well, if we know that 2/3 of them are yellow, and because we haven't gotten any more information, we're assuming that this is all of the jelly beans.
That's a good point. That's a good point. We have no other jelly beans in that jar. There are no greens or no blues.
I'm not messing around with you. Those are all of the jelly beans that are in there.
Okay,
There's no
all
different
right.
colors.
That would make it a lot harder, wouldn't
Yeah,
it?
that'd be a mystery. Okay, all right, moving on.
So that leaves, if we have, what's it? We'll just start with this. That's all of our jelly beans.
Okay.
But
I like
thirds. So we know that yellow is taking up 2 of them.
Okay.
And that red and orange both fit in here.
I like it.
But we have the numbers for red and orange. So we know that 5 of them are red and that 7 of them are orange. So that will, together, will give us 1/3. So we need to do that, which is, we'll make it a little bigger. And then comes the part that is so simple, I do it on a calculator all the time, so I now need to use my fingers.
Hey, and you know what? We've got students at home that do that all day long.
And I tell kids, use your fingers if you want
It's
to.
a tool.
It makes use whatever you want.
It is a tool,
Right.
right? I totally agree with you. I mean, if you've got a tool, use it.
Yeah.
Fabulous.
So we know that if that all comes up to 12, that means that this third here also comes out to 12. And then we have 12 is 1/3 of it.
Mm-hmm.
So we want to times that by how many we have, how many portions we have, which is 3.
Mm-hmm.
And that is what, 36?
Yep. Perfect.
So
Agreed.
to 36
Right?
jelly beans,
and,
right?
And if we didn't want to multiply, we could go back and just label our other ones. We know a third is 12, so this third has to be 12, so this third has to be 12, and we could add if we wanted to. It's amazing.
I mean, that's really what multiplication is, just repeated addition.
Absolutely, I love it.
There you go. I'm
love
glad you guys
it.
were able to do it. 2 different ways again. 12 times 3, and that is 36 total jelly beans. Hey, Kern Math Week is coming up. This is coming up the week of October 23rd through the 27th. Emily was nice enough to come in yesterday and give us a little heads up on that. Play some games with Savia yesterday, and she was able to take those games home with her family. So this is a lot of fun. We did it last year with Kern County. We're doing it again this year. So Kern Math Week coming up. All of the information is right there on your screen. You can always go to our website to find out more. And we'll be back with more right after this.
You've probably seen a big thunderstorm cloud roll into town, and the thunder, lightning, heavy rain, and gusty winds are hard to miss. But where did that thunderstorm come from? All thunderstorms follow the same recipe. To form, these storms require 3 basic ingredients: moisture, unstable air, and lift. Moisture in the air typically comes from the oceans, and areas near warm ocean currents evaporate lots of moisture into the air. Moisture in the air is also responsible for making clouds. Unstable air forms when warm, moist air is near the ground and cold, dry air is up above. To create a thunderstorm, the unstable air needs to have a nudge upward. This lift usually comes from differences in air density. warmer, less dense air rises upward, creating lift. As the air lifts higher and higher, it causes the storm cloud to grow taller and taller. Thunderstorm clouds can rise up to 10 miles into the air. In a big thunderstorm cloud, there are now strong upward winds and downward winds happening at the same time. These are called updrafts and downdrafts. This is the most dangerous stage of the storm, when tornadoes, hail, winds, and flooding can happen. Updrafts continue to fuel the storm with warm, moist air. But once a storm runs out of updrafts, it starts to weaken. As the storm begins to slow down, the rain and wind become less intense. And by the end, all that's left is a blue sky and an anvil-shaped cloud top. Phew! Glad that's over. Sure, a storm will probably come again, but you don't need to worry. Forecasters can use weather satellites, like those in NOAA's GOES-R series, to monitor clouds as they grow into thunderstorms. GOES satellites watch out for lightning, too. These satellites are constantly watching for severe weather, and the information they gather can help people stay safe during storms. Find out more about Earth's weather at NOAA Sijinks.
Roughly every year or two, somewhere in the world, the sun appears for a few moments as a ring of fire in the sky. This is called an annular solar eclipse. Annular comes from the Latin word annulus, which means ring. An annular solar eclipse occurs when a new moon passes directly in front of the sun but appears too small to cover it completely. But why is that? It's because the moon's orbit around Earth isn't a perfect circle, but rather an ellipse, or slightly oval-shaped. This causes the moon to move closer to us and then farther away during its month-long orbit. When the moon is at its closest point, called perigee, it appears slightly larger in our sky. When it's farthest from us, at apogee, it appears a little smaller. But we don't see an annular eclipse every month. That's because the moon's orbit is also slightly tilted in relation to Earth's orbit around the sun. This means during most months, the moon is either too high or too low to block the sun. So only when a new moon is at apogee and passes directly between Earth and the sun, do spectators on Earth get the rare opportunity to see the ring of fire in the sky. Unlike a total solar eclipse, when the moon completely covers the sun, during an annular eclipse, the sun never fully disappears. So if you're lucky enough to be in the path of an annular solar eclipse, make sure to wear your solar eclipse glasses or use other safe solar filters to witness this spectacular ring of fire in the sky.
And that is coming up the 14th of this month, so only in a couple of days you'll be able to see that eclipse. So mark the calendars, the 14th, be able to head out and you check that out. Colby, you did some excellent work today.
Thank you.
So I know you didn't plan on being here for the whole
Not
hour,
at
but we
all.
certainly do appreciate you hanging out for the whole hour. And I just left up on the screen one more time that first problem, because I know there are quite a few students that will be going back to the YouTube to check out this problem because they're working on this all week. And just an example of how you could do that problem. And it's simple, just doing the percents, then turn them into decimals, get the fractions, and that's what students need to do as far as the math part of it. And then the art part of it, they'll do better than what we did in here and just scribbling, and then they'll do a lot nicer with that right there.
Yeah.
But hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.